Good morning, students. Today's topic is plastic. Let us recollect what we have discussed in the last class. So what we have discussed in the last class: introduction to polymers, definition of polymer, monomer, and polymerization, and types of polymerization. So once again, we will revise these definitions and types of polymerization. So what is polymer? Formation of polymers from monomers is called polymerization. It means this is the exact definition. Process of formation of polymers from low molecular weight molecules of same or different compounds with or without elimination is called polymerization. Polymer means a high molecular weight macromolecule formed from monomers by polymerization is called polymer. And what is monomer? A low molecular weight molecule undergoing polymerization to form polymer is called monomer. The next you have types of polymerization. And the types of polymerization in your syllabus, you have two types of polymerization, that is addition polymerization and condensation polymerization. This addition polymerization is also called as chain growth polymerization. So polymerization in which monomers are added together to form polymer without elimination of simple molecules is called addition polymerization, and these polymers are called addition polymers. That means when monomers are added, there is no elimination of molecule. That type of polymerization is called addition polymerization. So in this polymerization, only unsaturated compounds are involved. And in this, whatever the monomers are involving, those monomers will be absorbed in the polymer. And here, monomers are added to the growing chain. That's why this polymerization is called chain growth polymerization. Best example for addition polymerization is polythene. Ethene is undergoing addition polymerization and we are getting a polythene. The next come to the condensation polymerization. This condensation polymerization is also called as step growth polymerization. So polymerization in which monomers are added together to form polymer with elimination of simple molecules like HCl, H2O, CH3OH, etc. is called condensation polymerization, and polymers are called condensation polymers. So when in this polymerization, when monomers are added, here elimination of molecules will take place, that is HCl, H2O, CH3OH. So that type of polymerization is called condensation polymerization, and whatever the polymers are forming, those are called condensation polymerization. And here what is happening? Molecule is eliminating, so that's why it is also called as step growth polymerization. And in this polymerization, so which type of monomers are involved means which are having functional groups. And the monomers, whatever the involving, those monomers will be not absorbed. Somewhat less number of monomers will be absorbed in the polymer. And these polymers are having cross-linked structure. Those are having straight chain structure. And these are high molecular weight. Those are low molecular weight. So this is the example. 9966 is the example for condensation polymerization. So one adipic acid is reacting with two hexamethylene diamine. So this carboxylic group react with one hexamethylene diamine. This carboxylic group react with another hexamethylene diamine. Like this, you will get a nylon 6,6 molecule. So this is the example for condensation polymerization. So these are the topics we discussed in the last class. So today's topic is plastics. Okay. So after completion of this period, you will be able to understand these topics. Plastic types, advantages, disadvantages, and characteristics of plastics, differences between thermoplastics and thermosetting plastic. So first of all, you should know what is meant by plastic. So in this polymer unit, we will deal with plastic and rubber. So our first today's topic is plastic. First of all, you should know what is meant by a plastic. So this is a polymer. Plastic is a polymer. So how will you define? A high molecular weight polymer. So this plastic is a very, very high molecular weight, which can be molded into any shape. That means we can make it into any shape. Whatever shape you want, that shape you can make by applying heat and pressure in the presence of catalyst is called plastic. So by applying heat and pressure, you can make it to any shape in the presence of catalyst. Catalyst is a substance which enhances the rate of reaction without participating in the reaction. So without participating in the reaction, just it enhances the rate of reaction. So the substance is called as catalyst. So to prepare, here we will use a catalyst. So it is a high molecular weight polymer which can be molded into any shape by applying heat and pressure in the presence of catalyst is called plastic. Okay. The next come to the characteristics of plastics. So all of you know these general things. What is the first characteristic? They are light in weight. See, they are very, very light in weight. They are good thermal and electrical insulator. It's the best insulator. So they act as good thermal and electrical insulators. They are highly resistant to corrosion. It means they will not undergo corrosion. Plastic is non-corrodable substance. They possess shiny and glossy surface. That means glossy means smooth surface and they are having shiny character. They are highly transparent and translucent. So if you observe the plastic, some are very, very transparent, some are translucent. Transparent is visible, translucent, somewhat thick. They are insect resistant. That means they are not at all affected by insects. They have low thermal expansion coefficient. So thermal expansion coefficient is very less. They have high refractive index. So these plastics have high refractive index. So these are some of the characteristics of plastics. So what is the first characteristic? They are light in weight. They are good thermal and electrical insulators. They are highly resistant to corrosion. They possess shiny and glossy surfaces. They are highly transparent and translucent. They are insect resistant. They have low thermal expansion coefficient. They have high refractive index. Then next is the advantages of plastics over traditional materials. The introduction itself we studied that polymers will have more advantages. That's why traditional materials are replaced by these polymers. So here also advantages of plastics over traditional materials. So compared to traditional materials, what are the advantages of plastics? So whatever the points we covered in the characteristics, same points we covered here also. So first one, they are light in weight and low cost. They are light in weight and its cost means rate is very less. Resistant to corrosion. They will not undergo corrosion. Resistant to insects. They are not at all affected by insects. Good thermal and electrical insulator. This is also a best advantage, good advantage. Whereas iron is an insulator, okay? Conductor. Whereas these are plastics are good thermal and electrical insulator. Insulator means current will not pass. Easy fabrication, can be fabricated easily. Different colors can be obtained. So wood and iron, if you take, they will be available in only one color. Whereas Plastic will be available in very different colors. Easy maintenance. So they can be maintained easily. That means easy to carry from one place to another place because they are lightly made. They are transparent and possess shiny surfaces. So they are transparent and possess shiny surfaces. So these are the advantages of plastics over traditional materials. Then next come to the disadvantages. As plastics have advantages, some disadvantages also there. So what are the disadvantages of using plastics? So if you use plastics, some disadvantages are there. So what are they? They are soft in nature. So they are very, very soft. So that is also one disadvantages. These are not suitable for cooking. So we can't cook food in these plastics because they are very soft in nature. So they are not at all suitable for cooking. They are non-biodegradable. They are not degraded by even bacteria and microorganisms. That is also one disadvantage. So they are non-biodegradable. They cause pollution. So they will not undergo corrosion. They remain in the soil itself. So they causes pollution. They have low heat resistance. That means they are not at all low heat resistance. When heat comes to them, they will become soft. So they are less resistant to heat. They have low ductility. So in metallurgy, we say ductility means the property which make into thin wires. That means ductility property they have very low. So we can't make into thin wires that much easily. They are sensitive to chemicals. So when they kept in chemicals, they are very, very sensitive, they will spoil. So these are some of the disadvantages of using plastic. Main disadvantage is this one, pollution. When you burn any plastic material, they releases some poisonous gases. That poisonous gases will release into the atmosphere. Due to that, it causes pollution. This is very, very dangerous one. Okay. The next types of plastics. And these plastics are again divided into two types based on the heat treatment. That means when they are heated, what is happening based on that, plastics are classified into two types. That is thermoplastics and thermosetting plastics. Thermoplastics, thermosetting plastics. These thermoplastics are also called as thermosoftening plastics. These thermoplastics are also called as thermosoftening plastics. So what is meant by thermoplastic? We'll see. Plastics which are softened on heating and hardened on cooling are called thermoplastics. So what is meant by thermoplastic? When you heat, they will become soft. When you cool, they will become hard. That means when you heat it, it will melt. When you cool it, it will become hard. So that type of plastics are called as thermoplastics. So these are called thermoplastic. Thermosoftening. That means when they are heated, they become softening. That's why these are called thermosoftening plastics. Example for thermoplastics, polythene, PVC, and Teflon, and so on. Very few examples I have given here. That is polythene, PVC, Teflon comes under thermoplastics. And then second one is thermosetting plastics or thermohardening plastics. Thermosetting plastics or thermohardening plastics. Plastics which are hardened on heating and cannot soften by applying heat and pressure are called thermosetting plastics. So these are the plastics which are hardened on heating. When you heat the plastic, it will go on hardened but cannot be softened. Even by applying heat and pressure also, they will not soft. Just they will become hard and even more they will become black. So that type of plastics are called as thermosetting plastics. Okay, they are hardened in heats but cannot be softened even by applying heat and pressure. So that type of plastics are called as thermosetting plastics or thermohardening. That means when they are heated, they are those are hardening. Here when they are heated, they soften. Here when they are heated, they are hardening. Okay. So that's why these are thermo hardening. Name itself gives the definition. Thermo softening means when they are heated, soften. Here when they are heated, harden. So thermo softening plastics, thermo hardening plastics. So examples for thermo setting plastics are thermo hardening plastics, polyester, bakelite. These two are examples for thermo setting plastics and are thermo hardening plastics. So, okay, plastics are divided into two types based on the heat treatment: thermoplastics, thermosetting. These thermoplastics are also called as thermosoftening plastics, and these thermosetting plastics are called thermohardening plastics. So when they will be softened, when they will cool, they become hardened. Whereas these are when they heat, they harden. They cannot soften. So that type of plastics are called thermosetting plastics. So examples for thermoplastics, polythene. Only one example you can remember if you want. Okay. Or two, minimum two examples. PVC, polyvinyl chloride. In preparation, you get this one. And it is polyester and bakelite. This one different plastic, this are different plastic. Okay, these are the types. And come to the differences between thermoplastics and thermosetting plastics. Differences. You have to differentiate between these two. What is thermoplastic, what is thermosetting plastics. So first difference is the definition. Plastics which are softened on heating and hardened on cooling are called thermoplastics. There is plastics which are hardened on heating and cannot be softened by any means. Any means means by applying heat, by applying pressure also, they are not softened. So that type of plastics are called as thermosetting plastics. Sorry, here polymers. Thermosetting plastics. Thermo thermosetting plastics. Plastics. Okay. Then second, plasticity is reversible. Means here on heating, softening takes place. On cooling, hardening takes place. That's why plasticity is reversible. Then here, plasticity is irreversible. That means on heating, it is becoming hardening. Okay. And they are not at all softened. So that's why it is irreversible. Here forward reaction is there, backward reaction is there. That's why plastic nature is reversible. Whereas it is no forward reaction only, not backward reaction. So it is irreversible. Next, these plastics are formed by addition polymerization. That means thermoplastics. These thermoplastics are formed by which polymerization? Addition polymerization. And these are formed by condensation polymerization. These thermosetting plastics are formed by condensation polymerization. So whatever the characters you are getting for this addition polymerization and condensation, those characters will get for thermoplastics and thermosetting plastics. So these are linear in shape. So in addition polymerization, we study now what is the structure. They are straight chain. So linear in shape. So whatever the thermoplastics which are prepared from addition polymerization, their shape is linear. Whereas these are cross-linked in shape. So whichever the polymers. So these plastics prepared by condensation polymerization, they are cross-linked in shape. And these polymers have low molecular weight. And these are having high molecular weight. These are weak, soft, and less brittle. These are strong, hard, and more brittle. These are weak, soft, and less brittle means which brittle means easily breaks. Less brittle means they are not easily breaks. They are strong, hard, and more brittle. That means they easily breaks. They are hard in nature, no, that's why easily breaks. They are soft in nature, they that much not easily breaks. They are soluble in organic solvent. That means when you dissolve in the when you keep in the organic solvent, it will be dissolved. These are insoluble in organic solvents. When you keep this plastic in the organic solvent, they will not dissolve. Adjacent chains are held by weak van der Waals forces. So it is a chain-like structures. All side-by-side chains are by which forces? Weak van der Waals forces. That's why they will soft when they are heated. That means when you heat, they undergo soft. Why? Because due to this weak van der Waals forces.